Welcome to an evening with Nick Dunhill, who is a member of the Guild technical team and a respected locomotive builder. If anyone has any specific requests, please let us know via chat so Nick can cover those too. Welcome, Nick. Thank you for joining us. Over to yourself.
Hello, everybody. Thanks for coming along this evening. And thank you very much for those joining us at some ungodly hour overseas as well. Nice to see you all. I'm sure you all know, but for those for whom this is their first time, this is a charity build that I've been doing. Well, it started off as various presentations for an evening with, but since it's kind of morphed into a charity build. The fella who's eventually going to have this loco when it's finished is going to make quite a hefty donation to a charity that's called Water Aid, that do a lot of work in the developing world, providing sanitation and various other things, which, you know, given the political situation at the moment in the world, that's become even more important. So if any of you feel like you could make a small donation, no matter how small, please go to the link in the on the Guild website for this presentation, and you'll find a link to a Just Giving page. And if you could make a small donation, we'd be really grateful. And so would all the people in the developing world that will benefit from this. I suppose I have to do a bit more housekeeping, because a few of the traders that are connected with the world of O-Gauge have made some very kind donations to this build as well, and I'm obliged to run through them. So there's Mick Davis, who's quite a well-known loco builder, and he does some very, very good 3D prints, and he's donated a load of 3D prints to this at cost. Diane Carney's etched the nameplates at cost. Laurie Griffin donated all of the inside motion. A guy called Mike Hopkins has done some fabulous 3D wax prints, from which he's had made a load of castings that will eventually go on the back end of the loco, but we'll come back to those a bit later as a bit of a spoiler. Sorry, a bit of a spoiler, a bit of a taster for the next an evening with. And then there's Rob De Boer at Model Yard. He professionally fits DCC into locomotives. He's in Leeds, and he's donated a ESU lock sound decoder at cost. Brian Robertson's provided a free sound project for it, and Bill Connell at Premier Components has given us a motor and gearbox, one of his PC 522 motor and gearboxes at cost as well. And all those, you know, without all those people, we'd have struggled a little bit to get this one together. So a big thanks to all those people. I suppose we ought to do a catch up.
Nick, sorry, quickly, just need to check. Yes. For anybody going to Kettering this weekend, Mike Hopkins is demonstrating at Kettering as well.
Right. Okay.
Thank you.
Very good. Very good. You may have, for those of you that went to Wigan, you would have seen that I made a back head while we were there. That's very simply made from a couple of pieces of brass, one that's keyhole shape, and then a kind of a strip that I've soldered around the edge of it and then filed the edge. It's all been sort of embossed with rivets and so on. Also, if you came to the virtual show earlier this year, you would have seen that I installed inside valve gear in this loco, and there was a video connected with that shows you how I made the crank axle that you can see inside the chassis just there. I've taken all the inside motion out of it now so that we can work a bit more on it tonight and then clean it afterwards. So it'll need to be stripped anyway for sticking it under a tap to clean all the flux off the model. I think that's kind of it. Oh, I did off camera sort of fettle a lot of these 3D prints that Mick Davis did for me. I tell you what I'll do. I'll switch you over to overhead cam so I can show you these in a little bit more detail. Bye now. There we go. As you can see, Mick's printed these really nice prints here. and they're of springs and hangers. And if you can see, there's a kind of a structure here at the top that goes over the horn guides, the homemade horn guides here that I put around the axle boxes of the loco. And a little bit later, you know, before we come to paint the loco, I'm going to just glue those over the horn guides that I put in one of the earlier videos, and that'll finish them off quite nicely, you know, and then they can go off to paint. Also, I've got some 3D prints for the spring that goes above the radial truck here. And you can see that what I've done is soldered a little piece of brass tube there into which the spring fits like so. But these are a bit difficult to fit because you kind of have to put them in there as you put in the body on the chassis just for access. So that's all a little bit awkward. But anyway, we'll perhaps come to that in a future video after we've persuaded Warren to paint it. So that's covered the 3D prints. They're all there waiting to go. Also, you can see I've added some 3D printed sandboxes that Mick Davis again did for me. And I've put a little piece of 0.8mm rod there and here at the back to represent the sanding pipes. These locos didn't have steam sanders at all. The sanders were gravity fed, so there is actually a mechanism. I've put a representation of the mechanism for the sander just there. It's kind of like a crank with a reach rod that goes into the cab, and there are some handles there. If you can see those just inside the cab there on the sort of sandboxes and splashers. So that's that. Now the other thing that I did while you weren't watching, in fact I did it a couple of weeks ago when it was pouring down outside and I couldn't go and play with my motorbikes. I thought it'd be a good idea to make the bottom of the cylinder block. So I'd already made a front and a back, and the front had these really nice cast cylinder head covers on them that came with the Laurie Griffin set. So what I did was I just cut out a rectangular plate to fit inside the void between the cylinder front and the cylinder back. And if you can see, I don't know whether you can see, I actually mounted some cylinder drain cocks on there because you can see them, you know, you can see the cylinder drain cocks, so that'd be a good idea to put them on. And then you can see I've put some pull rods there as well to represent the linkage. And then the linkage is connected via some cranks to this pull rod here. And I was pretty certain that this is how they work because you can see that pull rod there between the radial truck wheel and the first driving wheel. You can see that on the photographs that somebody kindly sent me of these locos. So they've all been added off camera. I thought it'd be a good idea to do all those before I put the brake system on because there might be an access problem once the brakes are fitted up. But I think what we'll do tonight is we'll have a start with how I've made the ash pan for this loco. And then also the way that the loco is designed, I think it's convenient to put the pickups inside the ash pan as well. I'll show you all this in a minute. I kind of like all the pickups to be hidden on a loco, especially if it's, you know, like this loco, it's got inside motion. So you're likely to go peering underneath the boiler. I think it's better if the pickups aren't there. I think it just looks a little bit nicer. But anyway, we'll start by having a look at the ash pan and the bottom of the firebox. So this, back to the drawing of the loco. This section's obviously the firebox, and the firebox extends below the footplate, so the grate of the firebox is down here. And whoever's drawn this has kindly put some kind of dotted lines in the drawing where the firebox would be. Now the reason I thought it'd be a good idea to put the firebox and the ash pan into this loco are twofold. Firstly, because you can see it dangling down the bottom of the chassis, and secondly, it conveniently covers up the chassis of the gearbox here. Obviously, the gearbox will be connected to this axle, and the gearbox then will fall within the ash pan. So I thought it might be a good idea to cover it up. So really, when you're making an ash pan, you have to kind of think about where it is and how it's located between the frames. If you think about what you can see on the top of the loco, really this is just the boiler cladding. It's not really the boiler. The boiler's, kind of a few inches underneath that. And the firebox is the same. This is just cladding over the firebox. So the firebox would be designed to sort of drop down between the frames. And usually if you go and have a look at a loco, you'll see that there's a gap between the inside of the frames and the outside wall of the firebox. So I know what the basic dimension is between the inside of the frames, and the plan was therefore to make the bottom of the firebox slightly narrower than that. But first of all, what I did was I looked at the drawing and found out what the shape of this was. The bottom part of the firebox that basically is from the footplate downwards, and I kind of drew that, and it's kind of a sort of a, would you call it a rhombus or a parallelogram? It's sort of that shape. It's kind of slopey at the bottom, and the bottom of it's got a row of rivets on as well along the bottom like that. So the first step was obviously to pick up these dimensions off the drawing and then cut them out of brass, sorry, nickel silver. And you can see that that's that part of the firebox. And obviously I made another one for the other side, and then a piece to go there and another one to go there. And those dimensions are very simple. They're just picked up off the ends there for the vertical, and the return there is the thickness, the width between the frames, less a little gap. And I sort of just got some scrap brass, which is 0.45 mil. And if you can see, I've soldered some strips of 0.45 to the top. So on there, like that, is a piece of 0.45 mil to give you a gap between the inside of the frames and the outside of the firebox. So now you can work out that dimension, and then you cut these pieces out and you solder yourself up a box like that. But of course, what I did is I forgot to put the rivet detail on. So you can see the rivet detail here is represented by a strip, a rivet strip. It's just a thin strip of a half-etched brass that's got rivets etched into it. And I just, yes?
Any chance you can just hold that closer to the camera?
Can you see it there? Is that better? Is that better?
Not really, no. It's all right, don't worry. I think it's the light reflecting off it, is why we can't see it as well.
Is that better? Let's just try and dim the light a little bit. Does that help? No?
Ah, yeah, there you can just make out a little bit.
Yeah. There's a strip there, a brass strip. It's just a very thin. I buy it from, I can't remember who I get it from. CPL, somebody like that, and they just sell an etch that's just got strips on it. So they're half-etched strips of various thicknesses, and some of them have got rivets along the strip as well, and they're really useful. So I always end up buying those. Anyway, so we've got the top bit of it there now, and then similarly, underneath the bottom of the firebox, you have an ash pan. where all the ash that falls through the grate ends up. And again, that's represented on the drawing. Where did I put the drawing? There it is. It's represented on the drawing. You can quite clearly see it's been drawn here, and it's sort of this structure here. So it's very easy to pick the dimensions up of that. And again, I just transferred the drawing, the dimensions onto a piece of sort of brass nickel silver that looks like that. And if you can see, the ash pan is inside the firebox. You can see there's a step in it, and I achieved that in the same way by soldering a piece of 0.45 mil scrap to the top edge of it, making it that much bigger. So the top of this structure is increased by the width of the strip that I soldered onto it. And then you can solder this on the inside of here and then carry on all the way around, making that piece, that piece. And if you can see, I didn't make the back there because the gearbox pokes through there and starts to interfere with the back of the ash pan, because the gearbox obviously sticks out of that. But I have put this piece on with the intention of taking it off after I've put the ash pan in the loco. So when I solder this inside the frames, the plan then is to just warm this piece up and ping it off so that there's access for the gearbox out of the rear of the ash pan. So that's kind of how I did that. I mean, then I put a bottom on it. I suppose the bottom's not really necessary, but I've done so much work on it by then. I thought it'd be quite nice to have a bottom on it because it'll kind of hide the bottom of the gearbox a little bit should the loco ever fall over or something like that. I don't know. The other thing that I did in anticipation of pickups, because I think we were going to talk a bit about pickups tonight as well, was that you see here, I drilled a hole there in the corner of the ash pan. Now that is for the pickup to poke through. And I've done one on both sides. And I did that by temporarily tacking this inside the frames and then marking the position of the tyre on the ash pan so that the hole is right behind the tyre of this front driving wheel. And in that way, I can mount some phosphor bronze pickups on these bits of PCB printed circuit board that I've already glued inside the ash pan. You can see there's one there and there's one just there as well. And in a minute, I will endeavour to put some phosphor bronze wire in this, ready for use as a pickup. In fact, I think we'll do that right away. So here I have in my little drawer of goodies some very thin phosphor bronze wire that I get from Hobby Holidays in Gainsborough or wherever it is that Phil's moved to. Of course, this is available from other suppliers, but it is very thin. I think it's 0.6 millimeter phosphor bronze, so it's quite springy, but not very stiff because it's so thin. It is 0.5 in actual fact. So that's 0.5 millimeter phosphor bronze. So if we kind of temporarily just pop the ash pan in there, and what I need to do now is to try and get a dimension from the face there of the PCB, bit of PCB that I've glued inside, and the tyre there. And if I find my little measuring stick, which seems to have disappeared off my table right now, but I was measuring a bike with it earlier. It's kind of roughly about 3.5, shall we say 5.5 millimeters. So if we get a pair of pliers, thin-nosed sort of pair of pliers, and make a U shape on what I've done is made a U shape on the end of the phosphor bronze wire. And what I'm going to do for an extra bit of belt and braces is earlier, before, when it was just me and Alex waiting for everybody to turn up, I cut these little tiny pieces of insulation. All they are is just a piece of the PVC insulation on a bit of wire. And I chose fairly thick wire so that I could thread the 0.5 millimeter bit of phosphor bronze wire through that piece of insulation there, so that when this piece of phosphor bronze is sticking out through the hole in the ash pan, I've got a piece of insulation around the wire that will stop any electrical contacts there. So that's that. And then what we'll do is we'll make another bend about 5.5 millimeters away from the point of contact on this phosphor bronze wire. It's about there. So now we've got this phosphor bronze wire bent into kind of this shape. So it's kind of like that, and like that. And the insulation is just there to insulate it where it passes through the ash pan like that. I switch my soldering iron on. We'll be able to solder that in there like so. If you can see, what I've done is I've passed the bit of wire through the hole, and then I'm holding the piece of bit of lead block there to stop me ash pan walking away while I press. So this end of the pickup goes through the hole in the ash pan there, and this end of the wire is resting on the PCB there. So if I put a bit of flux on it, and then you get a nice bit of solder there off the reel of solder, we can have one last look, make sure that the contact's sticking horizontally still, and we'll solder that onto the PCB like so. And then we'll get me cutters, cut the extra bit off, and then we'll very quickly repeat the process. Bend the end of that, stick a piece of that through there, measure it on there. You see, making pickups like this is very, very quick. Bend like so, shove that in there. This is where you need to be left-handed, and I ain't. Put that on there like that, and then try and solder it. So do that, and then with a bit of luck, these pickups will be in exactly the right place when I come to put the ash pan in the loco, which I'm going to do next. Let's just have another go at pre-tinning this piece of PCB. I think the problem with the PCB is it's got a bit of super glue on it. So where the super glue comes through the holes in the PCB, there's holes in the bit of printed circuit board where the component legs go, if you were using it for an electrical component. And I think the problem there is that, of course, it's doesn't act as doesn't leave you a good surface to solder on. Let's have another go. There we go. That's done it. Excellent. Right. So now we've got a. Let's just straighten up. Oh, you're not straight, are you?
While you're just doing that, Nick, were the rivet strips from ragstone?
No, they weren't.
Right.
They're
Okay.
from. I can't.
Rob
Honestly,
Fulham suggests they were Springside.
Yeah, but I can't find anything on Springside's website or CPL's website.
Yeah, I had a look at
And I'll
CPL. I
tell
couldn't see
you
it.
exactly where they're from. They're from a company called Scale Link. Look
Ah, Scale Link. Yeah,
there.
brilliant.
I've got loads and loads and loads of them because I only ever use. I seem to burn through certain ones much quicker than others. So I always seem to have lots of the junky ones left that I don't really use. There we go. That's got that straight now. So there we've got a ash pan, look, with two bits of PCB, two pickups sticking out through the ash pan. And I think what I'm going to do now is just put a tiny blob of super glue on the insulation to hold it in place where it sticks through the ash pan. So we'll just do a bit there and pop there. Right. So next stage is to solder the ash pan into the loco. So this surface here on the chassis is where the footplate lands. And if you remember, the measurements that we took were from the bottom of the footplate, which is where this sits. So what we need to do is pop the ash pan in there, like so. Got to do with that. This is a bit where you need a third hand. So the pickups now are impeding me. There we go. So maneuver that in there, like so. And what I've got here is a handy piece, just a flat piece of aluminium. So I'm just going to rest that on the top of the chassis and then push the ash pan up against the piece of aluminium block so that I know that the whole thing now is flat, is flush with the top of the body, top of the chassis, sorry. And then what we'll do is we'll get a little bit of flux on there and we'll tack you on that side there. And then we'll tack you on there, like so. We'll just check that our ash pan is looking good, and I have to say that it is. That looks pretty good to me, and if I compare it with the drawing, it's pretty much exactly right, with a tiny bit of the bottom of the firebox sticking out below the chassis. I hear you all ask, why did you bother making it if there's only a tiny bit sticking down? But there we go. So I think I could solder it there and there as well, and we'll call that fitted up. So tack there, and we'll make that into a proper soldered joint, like so. Up to the same there. Excellent. So that's the ash pan installed in the loco. And what we'll do is we'll just use the rotary sander just to clean that up. And were my measurements correct, I hear you ask? Well, yes, of course they were, because I checked before we started. And there you can see, look, that the phosphor bronze now engages with the back of these two driving wheels. So there we go, that's all nicely done. And also, I said that we would be brutal now and take this front piece there out so that we've got access for the motor. Now, of course, I only put that in to hold the ash pan rigid while we soldered it into the loco, and it's just got a couple of tacks in the corner there. So hopefully if we just hit that with the soldering iron, we can break this piece out. There we go, that's one side gone. Brutal. Be brutal, Nick. There we go. So that goes into the bin of shame over there. And there we have an ash pan installed in the loco that'll quite nicely give us access there. And I know it fits because I measured it earlier for the gearbox to fit quite nicely and reach the rear axle. And if you can see, look, we've even left a cutout there, look, in the bottom of the ash pan to clear the gear wheel as well. So there we go, that's that bit done. Now I've also soldered a couple of pieces of PCB, soldered isn't the right word, glued's the word, just there onto the rear drag beam of the chassis. So what I'm going to do now is just pop these wheel sets in. Don't have to be located accurately. We'll just pop that back in there and screw it in, and then we'll make the two pickups for the back wheel. I have to confess to you all that I only ever use phosphor bronze strips for pickups. And I know a lot of people's preferred sort of method of picking electricity up is via plunger pickups. And I suppose the most used ones would be the ones from either Allen Gibson or possibly Slater's, something like that. And I have to confess that I kind of never got on with plunger pickups. I don't really know why. But you know, if anybody has had a better experience and knows why I'm going wrong, then I'd be happy to hear from you. I think my problem was always that it just introduced a little bit too much resistance. So the wheels, you know, it was difficult to get the wheels to turn. I think with these phosphor bronze bits of wire, you can kind of tweak the pieces that you've put in down there. You can kind of tweak them a little bit so that they only press very lightly against the backs of the wheels, and they don't really, you know, introduce too much resistance then, you know, so the wheel's still relatively free to turn. And I think that really does help when it comes to trying to make a loco that's nicely, you know, nicely free running. So what I'm going to do here is I'm just guessing. I am just guessing here at the angles. So I've bent a piece of phosphor bronze. You probably won't be able to see that because my camera's rubbish. But anyway, I've bent it into a shape that hopefully will allow it to reach the tire down there, and it does. So if I rest that against the tire and simultaneously against the bit of PCB there that I've put in the already glued onto the chassis, I should be able to hit that with a bit of solder. Let's twist it in my hand. Let's twist it back. There we go. So here you go. And I think that's that pickup installed. Is it? Soldering. There we go. So that's one installed. Like so. So that's touching the bottom of the wheel. So we're happy with that. So we can clip the rest of that off, making sure that it won't touch the underside of the loco body. Chart it out. So that's very nicely touching the back of the wheel there. And then what we'll do is we'll bend the second one very quickly. Look at this, live pickups. Live pickups, look, in less than 15 minutes. Not about that. Get it all. You get your money's worth from the O-Gauge Guild, don't you? So if anybody could tell me where I'm going wrong with plunger pickups, I'd be happy to hear. Do you think it's the spring that comes in the plunger pickup that's a bit too bit too springy, a bit too. Would I be able to? I don't think I'd be able to cut turns off the spring because that kind of makes the spring even stiffer, doesn't it? I remember my dad having a conversation with me years ago over a restaurant table because he was an engineer, a proper engineer, not a made up one like me. And he explained to me that you just couldn't cut link turns off springs because the spring actually got stiffer in operation. And then did some calculation on the back of a beer map to prove it to me when I had said I didn't believe him. That's the sort of family we were. Engineering on family visits. Just going to put a little bit of glue on the back of these, just there on these sanding pipes because I've broken the glue. There we go. I should sort it out. So now we've got a loco that's got pickups and an ash pan. But you really don't want to watch me soldering a piece of wire from there to there and up to the motor. So we'll do that on another occasion when we come to install the DCC. And maybe we'll have an evening with or some sort of presentation where we put the thing on a bit of track down there on my floor and see if we can see it running. Or maybe go to somebody's club. That'd be even better, wouldn't it? Go to somebody's club. What do you think, Ian? Sure, we could arrange that, couldn't we? Right, moving on. Now, the bonus bit, I think, or I can't remember whether it was actually in the description or not, was the brakes, mucking around with the brakes. Now, conveniently, we've put the wheels back in. But what I haven't explained to you was how I planned to do the brakes. Now, I kind of used the system that you see used all the time in commercial kits, where you solder a piece of 0.9mm wire through the chassis and have it sticking out through the pre-etched holes. Obviously, we're scratch building, so we don't have any pre-etched holes. However, it is quite easy to work out where the pivot points are because they're obviously on the drawing here and here. So really all you need to do is find some datum point, whether it be the bottom of the chassis or the top of the chassis, and find where the pivot point should be and mark it out, and then take a measurement from the back of the chassis or wherever, you know, put a center punch, drill a hole, and there you are. Also, what I like to do, obviously with a loco like this, with it having inside motion, the brake gear is going to have to be detachable so that you can get the crank axle out of the loco. Otherwise, you know, I mean, the crank axle has to come this way out of the loco. So you can't have any brake rigging down here impeding its progress. Otherwise, it just isn't going to come out. So what I've done is, if we flip this over, we'll try it for you. So we've got the chassis rails like that, and now we've got our ash pan here inside the chassis. So the axle is kind of here, isn't it? Crank axle, all the cubbings and the doobie-doos here, the crank webs and all the eccentric sheaves. And so essentially what I've done is drilled a hole through the chassis and put a piece of, well, I said 0.9, but it's not, it's actually 0.6 through the chassis like that. And then I've chopped it off here and made it flush with the side of the chassis, the inside of the chassis there. And I've done the same thing here, although it did come into conflict, and I should have seen that when I looked at the drawing. These pivots here for the brakes on the front driving wheel actually go through the bottom of the what would you call it, the trunnion here for the way shaft, the inside motion. So I did actually have to drill a hole right through the bottom part of the trunnion there, which is fine because it kind of looks like a one of the bolts that holds it in place. And of course, I've got the added advantage now that the trunnions are pinned to the chassis, so they're not coming off ever. But what I like to do is I like to make a structure with the brakes. I'll show you in a minute, where you have a brake hanger, and then you have another brake hanger on the other side, and you have, in this case, a rod that goes all the way through the bottom. And on these locos, it is just a piece of rod and not a spreader plate, because sometimes this piece is kind of a spreader plate that's kind of that shape, isn't it? To hold this dimension here, to stop them doing the brake hangers doing that when you apply the brakes. But on this loco, they're not like that. So what I did was I make a structure like this and solder it up, and then I can spring these apart slightly to pop them over the tops of the spring hangers, get the holes over these pieces of these pivots that I've just added to the chassis there. So you spring them out and pop them on, and then spring the front one out and pop it on. I'll show you in a minute. But what I did to get this, to stop this moving sideways when it's on this pivot, is I got a piece of thin walled tube, cut some pieces and soldered them like that over these wire pivots there. And I don't know whether you can see that. Can you see that, Ian? Just there and there? Possibly, maybe. But that's what they're like, I promise you. And then if I take that measurement there, then I can make another piece of thin walled tube that's the same dimension there, and put that between the brake hangers. And here they are, look, ready made. This is the whole structure. You can see that I've cut a piece of thin walled tube there that's got an ID of 0.6, which is the diameter of this rod that I've used for pinning all of the brake rigging together. And then obviously there's an extension piece here coming out the end, because if you look at the drawing of these locos and all the photographs, you'll see that the pull rods for the brakes are outboard of the wheels. Often they're more conventionally, or on more modern locos, they're underneath the loco. But on these sort of Victorian models, for some reason, they always seem to be outboard. There must be a reason for that, but I'm not sure what it is. So anyway, what I do then is, when I've got these pieces of tube and that piece of tube made, then I can roughly assemble a pair of brake hangers and a piece of rod going through them with a spacer, this spacer at the bottom, and then connect that to the pivot like that on one side, like that on the other, and then you can lean this assembly up against the wheel so that that brake hanger becomes parallel and in line with that brake hanger. And I've missed a step out here, because as you can see, what I've done is Mick Davies kindly 3D printed me some brake blocks, which I've drilled and pinned to the, these are the hangers, and these are the brake blocks that Mick 3D printed. And you can see what I've done is I've pinned them to the brake hanger. And a little bit later, I just put a dab of super glue on the back just to hold the brake blocks in exactly the right position, so that the curved face of them is parallel with the tire. And then I kind of repeated this process with the back spring and hanger, and you can see that they also, if you pull them gently, they clip over on both sides like so. So at that stage, what you've got is one of these attached to the loco on the front wheel, and a second one attached to the loco here. And then you have to make this pull rod. Now, obviously, the dimensions of the holes in the pull rod are exactly the same as the dimensions of the wheelbase of the loco. They have to be, don't they, if you think about it. I must also, I suppose what I should have said right at the beginning of this was that I took the dimensions here off the drawing of the brake hangers and just cut those. They just cut out some scrap brass etch, the kind of scrap that you get between the components on a commercial kit, bit of loco etch or tender etch. And similarly, these strips here that I cut for the that I used for the pull rods are also just scrap etch. I think these were part of a coal rail, a leftover coal rail that I had for a tender or something like that, you know, and it just happened to have enough. There was enough length of strip to make all these pieces. So you need obviously a pair there to connect the bottoms of the spring hangers, one on each side, and then a piece here, which I measured off the drawing. There's a piece here, look, that goes from the rear spring hanger up to the crank here. And this is a crank that I cut out of some nickel silver there that's just taken off the dimension of this. You can see on the drawing that the crank here has a pivot there, but goes down to sort of 7 o'clock. But if you look at the photographs of a real loco, you'll see that the drawing's not quite right, because when the locos were rebuilt, there's a photograph, you can see that the crank goes up towards sort of 11 o'clock up here somewhere. And this is kind of much steeper than it's shown on this drawing, which was a bit of an oversight of whoever did the drawing. You can see the angle is much steeper than it is on this. So that's a kind of a modification that I made, or an amendment that I made to the drawing. I think this is correct. Now, these pieces here, this is just a piece of I had to make some extensions here to the chassis frame. I suppose if I'd have been a bit more switched on when I was cutting out the chassis years ago, I would have realized that there's probably a extension to the chassis here to support the brake shaft. But in any event, I just cut out a pair of pieces there, soldered them to the inside of the chassis, and then put this piece of, I think this is probably, looking at it, it's 1.16 nickel silver through there, and then made these cranks here out of, you know, some more scrap nickel silver strip. And the ends of these pull rods just drop into the bell crank like that, and all the brake rigging then's held quite nicely in position. What you have to do is just line up these pull rods by eye. Just leave yourself a gap of about 1 millimeter. Look at the end float of the wheels and push it to one side, and then measure another millimeter, and then put the pull rod there, so there's no danger that the tire is going to touch the pull rod, and then do the same at the other side. And then you have to kind of line it up by eye like that, you know, and make sure that they're straight and parallel to the chassis. And then these extension pieces then go to the bell crank. Then you can put the bell crank on and just quickly solder that to the brake shaft here. And also you can see what I've done just as a finishing thing is I was going to say I cut this out of another piece of brass strip. It's a lever that works the brake. The end of the lever's got a rod soldered into it that would have gone into the brake cylinder, but that's kind of where my information on the loco ran out. Look, because there's kind of a representation here on the drawing of a brake cylinder, but I don't think that's the right brake cylinder. That looks a bit too small. It looks like a cylinder that might be used on a loco that had air brakes. And this loco certainly never had, or didn't in this era, have a Westinghouse pump. So it's almost certainly got a vacuum brake. And you know, the vacuum ejector on a lot of these locos was hidden underneath the boiler clothing, or maybe inside the boiler somewhere. I just don't know. So I kind of didn't have any information about what was happening here. So I just put a lever there and dropped a piece of rod down there and left it at that, really. There's not really much else I could do, I'm afraid, with that. And also, if you look at the drawing, it shows it suggests that the loco had injectors behind the cab steps here. But again, if you look at the photographs of the loco that we're making, and we are actually making number 38, which is that photograph there, you can see that there's no pipe work at all at the back of the steps. So I think on the earlier versions, yes, the pre rebuilds of this loco show an ejector behind the back of the steps, and that's been deleted after the rebuild. So I'm guessing that the injectors for this loco were probably on the back head. And actually, if you look at the drawing here, you can see that there is a representation there of an injector there on the back head. So the drawing's kind of wrong and perhaps a bit misleading, because it's showing an injector here behind the step and another one here on the back head, and it wouldn't have had either. I've had both. And the drawing suggests that it's actually on the back end and not here behind the back of the wheels. So we'll move on from that. We're going to come to the back end in a future presentation. July, I think, isn't it, Ian?
I think you're right there, Nick. Yeah, I mean, we'll know at the end of the session, because I've got the
well, as a sneaky peek, Mike Hopkins, who you mentioned earlier, has done a really kind commission here for us. You can see we've got these amazing lost wax casting sprues here, and you can see there's loads of injectors there. We've got some gauges for the back of the cab. We've got a regulator handle, and these were all based on about a year ago. I built a Sterling single for a customer, and we had a drawing for the Sterling single, and Mike kindly copied all the pieces on the back end, and we got some castings made. They're made from 3D printed waxes. Now this loco was designed by Patrick Sterling's son, I think, and because of the family connection, it looks from this drawing, although as we've just described, it's not necessarily very reliable. This has clearly got a Patrick Sterling style Sterling single regulator on it. So that came kindly from Mike. But anyway, we'll come to all this later. I'm kind of giving you a sneaky peek of a future presentation. Then in the next live presentation in July, what we're going to do is I'll show you how I build a back end and put all the details on the back end. We'll try and find some way of condensing that into an hour and a half. Yes. So having done all this, I suppose the best thing to do, finish off the presentation, would be to just check that it all goes together, really. Oh, perhaps I won't do that, because this motor's got a shaft on the top and I really don't want to start grinding that off tonight. It'll make a terrible noise, and I think we'll run out of time if we do. Has anybody got any questions so far? I've been rabbiting on for an hour and a bit. Does anybody?
Just under an hour, Nick, and no questions at the present. Does anybody like to unmute and put a question to
Anybody
Nick?
like to know anything about what we've done? We've covered quite a lot in the last hour or so. So anything anybody would like to know? No, all right. Okay.
I'll just go on to pickups. What you were saying earlier regarding plunger pickups.
Yeah.
Personally, I'm like you. I've never liked them, and I think certainly the Slater's type, where you've got that horrible plastic bush that sits on the outside of the frames, sometimes actually fouls the wheels if you're not careful, depending upon the frame width.
I think they press out
They do, yeah,
too
yeah,
tightly.
and the Ellis Clark Black Fives, for example, they've got plunger pickups on the tenders, and they grate. They really do make a like grating noise. Whether
Do
it's
they?
just yeah, whether it's just because the Black Fives are new and they've not been running the plunger
Right.
hasn't had time to wear a smooth face on the tire or not, I don't know, but
Well, I have to confess that this type of pickup that I've been demonstrating tonight, they are a little bit noisy. You can hear them scraping on the
yeah,
back of the wheel. I mean, maybe you could get some contact cleaner, or you can get contact for switches, can't you? Kind of a
yeah,
lubricant that you
switch
spray
cleaner.
it. But I'm guessing that's probably not. Obviously, if you were spraying it into a switch, it wouldn't be conductive, would it? Otherwise, it'd short the switch
Um,
out straight away.
um, am I on audio? Can you hear me?
You
Yes, who,
can.
who is
Yeah,
who's
hi.
speaking?
The the brake rigging, you said is if I understand it, is removable.
It is.
So I can't quite understand how it's removable. If you could perhaps just show me, because I'm
Yes,
I'm
yeah, of
I'm
course. Yeah,
building a
yeah,
an SWR 700 class, and I'm extremely keen to have removable brake gear.
yeah. Well, back to this drawing here, you
Yeah,
can see that you can see how I've soldered up a brake hanger there with a brake block on it like that. I'm looking at it from this direction or that direction.
yeah,
And these are the pins here that are attached to the chassis. This sides of the chassis, and there's now some bits of tube here to act as spacers as well, but they're not soldered here or here,
right.
so you can just literally just gently pull the tops of the hangers apart like that, and they'll unclip if you take that out of the cranks first. You can
Right,
see
so you put a little bit of tubes on the outside of the
yeah, so the
frames.
tubes are attached permanently here to the chassis,
Yeah,
here to the chassis, but
yeah,
they're not soldered here or here.
right.
The hanger just literally
Ah, yes, yes, I
pull them
see.
apart and clip them onto the ends of these bits of tube.
Yeah, right.
You
Yeah,
can't do it too many times, otherwise the hangers start to splay out a little bit. But I
yeah,
mean, you
yeah,
can always bend them back in, can't you?
yeah, yeah,
But I
yeah.
mean, really, you only want to take them off and put them on once, don't you?
Yeah, sure, sure.
To
Yeah,
go to the painter, and when they come back, you can clip them back on. Well, you have to scrape the paint off the out of the holes and off the pivots as well, because the painter won't mask them up. So when they come back, there'll be paint over those.
so sorry, just to be clear,
Yeah,
there's a small piece of wire on the hanger which goes into the tube.
no,
No,
the bit of wire is soldered here to the chassis. Look, it's
right.
soldered into the chassis there.
You might need to
Okay.
just bring it close to the camera, Nick, a little bit.
Is
And
that a bit?
right, and so the tube goes over the wire.
The tube goes over the wire to act as a spacer,
I
like,
understand. Yeah, 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 yeah.
and the it's as if it was in a commercial kit, you would just shove a piece of
Yes,
rod, wouldn't you,
that's
through the chassis and solder it there, and then put the brake hangers on the ends of it.
that's exactly what I've done.
Yeah,
But
I always cut them off inside
yeah,
because it just looks a bit nicer, and also you can't have it continuous there because there's a motor and a gearbox here, isn't there?
yeah,
And
yeah.
similarly here,
Okay.
you don't want it going across there because it'll just interfere with the inside motion. So they just cut off. But this piece of tube here is just a spacer to stop the brake hangers, sliding off, going to one side and dropping off. And
Yeah,
there's also a spacer here at the bottom. This is it here. That's another piece of thin-walled tube. The internal diameter of that is the same as the diameter of the rod. So in this case, the piece of tube is 0.6 ID, which will mean it's 0.8 OD, because this thin-walled tube that I buy is 0.1 millimeter wall thickness.
Yeah, so I've used 0.9 mil wire for
So you
the
would need
rods that go through. So
you would need
I'm
1.1 mil.
1.1 mil brass
Yeah,
tube.
OD. The wall thickness is always 0.1. So
Okay.
it's always, 0.2 of a millimeter up. So if you want the internal diameter to be 0.9, then you have to go and buy 1.1. And it's
1.1
available.
tube.
Yeah,
Yeah.
you can buy this thin walled tube. Well, I always get my stuff from Phil Atkinson, because he's in Gainsborough, which is quite close, and he sends stuff out straight away. It's a very good service.
Right.
Sounds like I'm being paid to say this, doesn't it? But I'm not. But I mean, I used to get it off Eileen's like everybody else, but Eileen's
Yeah, she's
they
gone, I know.
closed down, didn't they? And
Yeah.
also, I got a bit ticked off with Eileen's because they were selling drills that were really cheap, but also they were really nasty. I was getting drills that were blunt before I'd even tried to use them. They were just really cheap carbon steel drills instead of high-speed steel. And somebody pointed this out to me at a show that I was buying really cheap drills. And I said, yeah, but you get through a lot of them, you get through a lot of 0.6 or 0.8 millimeter drills. And he said, yeah, but if you go and pay double or triple, you'll get a high-speed steel drill that'll cut a lot more holes and won't break as often. And you know what? He was right. So, and Eileen's didn't sell high-speed steel drills unless they were over a millimeter in diameter. But Phil Atkinson did so. And it's that thing, once you change your supplier, you end up combining, so you're not having to do two sets of orders for things. Because I do this commercially, I kind of let my stock run down to a couple of lengths of something, then I instantly reorder because you can't be sitting around for a couple of days waiting for your 0.8 mil rod to turn up, can you?
No.
So here,
All right, thanks for that. Yeah,
that's
I understand now.
Yeah, sorry, I didn't make that clear enough. My wife always said I wouldn't make a very good teacher.
Can I ask a question about
Yeah,
going back to the pickups?
Yeah.
Have you considered the American system?
Well, yes, I built loads of locos that are done to the American system, but usually when I've been using something like Allen Harris wheels, because people often send me Allen Harris wheels that have been turned, by Allen himself or somebody like Steve Ross, or Brian Clapperton used to do them as well, didn't he? And I think what's his name? East Side Pilot, Colin. What's his name?
Colin Dowling, who's just
Colin
retired.
Dowling. Has he retired now?
He's just retired, yeah.
Right, okay. Because he's the go-to guy for machining S7 wheels, isn't he? He's got a form tool, hasn't he, for them? Has somebody taken over from him now?
No, he's just retiring.
Oh, bugger. What about all these scale 7 engines I've got to make? Anyway,
I was told Richard Hersey, but I don't have any contact details for him.
Yeah,
right, yeah.
Richard Hersey did 3 sets for me actually.
Right, okay.
But it was quite a while ago. In fact, the set that the turbo motive you built.
Oh, yeah, hi, Paul. How are you doing?
Yeah, well that were Richard Hersey wheels.
Yes, they were. Yeah, I remember that. Yeah.
Yeah, I've still got his card, but whether he's still working, I don't know.
Well, Colin turned me some wheels the other day. I was making a model for someone. Anyway, we're digressing here, aren't we?
Yeah.
He did me something about 2 weeks ago, so it must be very recently when he's retired.
Yeah, he was winding down for the end of January, and I think he's now officially end of this month. I think officially stops, Nick.
Right.
Memory.
Oh no, what am I going to do? Anyway, we'll not worry about that too much.
Ian McCormack's raised his hand. Ian, yes, you want to ask a question?
I'm a member of the Scale 7 group, and there are 3 other suppliers going to be there to turn Slater's wheels to S7,
Brilliant.
including Ian at Slater's.
I know Slater's will do them, won't they? But my understanding is that Slater. Oh, I'm getting confused here actually, because a lot of the wheels I have turned I'd turned in the past by Colin. They weren't for scale 7; they were for broad gauge locos. But the track standards for broad gauge are very similar, apart from the track gauge, obviously, to the wheel standards for scale 7. just to make it even harder to make a broad gauge loco go around the corner.
Yeah. Right, cheers.
It's funny watching a broad gauge loco go around a corner because the gauge is, isn't it something like 49 millimeters? I mean, it's noticeably much wider than fine scale. And of course, people still want their loco to go around a 6-foot radius curve, you know, because they've only got a room that's big enough for that. And if you think about, I did a measurement. Because I've got a piece of test track down there, and I had to set the radius on my bit of test track to 5'5", would you believe? And I just thought that how much further does the outer wheel have to turn than the inner wheel? You know, and I can't remember how much of the arc of a curve that I measured. I probably measured from the straight section through the transition and onto the 5'5" radius curve. So it wasn't a very scientific sort of thing. But I'm sure the piece of track that I measured was about, I don't know, 30 centimeters or something like that. And the outer wheel traveled an extra centimeter. But of course, they've got fixed axles, haven't they? Yeah. So what happens when you watch the loco going around a corner is you can see it winding up. You can see that the loco's trying to go straight on and then all of a sudden the loco kind of flips as the outside wheel catches up with the inside wheel. It's quite disconcerting to watch it, really. So my advice to you is, if you're going to dabble with broad gauge, stick to broad gauge radiuses of corners as well. Otherwise, weird things happen. But anyway,
you were going to say build a differential.
Yeah, well, that's right. They don't come with a limited slip diff, do they? You know?
On both axles.
Yeah. Well, yeah, that's what you really want, isn't it? But I'm sure those kind of blacksmiths that made broad gauge locos hadn't discovered that, had they? Any more questions? No. I must confess, I've run out of things to show you here. I've kind of caught up on myself quite quickly. What else can I show you? What else have we got here?
How about well, as you've done the ash pan and things tonight and the brake rigging, how about showing us what it looks like with the loco body on?
Okay, we could do that.
Just a quick one before you get whatever it is in your box out.
Yeah, well, I was just putting them away, actually.
Okay.
Yeah, well, I'll tell you what. Then we'll put the brake rigging back on. You can see what I've done is I put the sandboxes on first. To make sure that they didn't interfere with the brake hangers, and I kind of did it arse about face way, where I put the axle, the ash pat, the sandboxes on first, and really I should have put the brake rigging on, but I didn't. So that brake rigging kind of goes in there like so, and if you just stick the ends of the pull rods somewhere there around where the crank is at the back, and then you can very gently put the hanger over that pivot, and then this one as well. Just needs a bit of bending out. So flip it over and do the same on the other side. As I said, they start to splay out eventually, these, if you do this too often. That's okay, you can bend them back, of course you can, and then pop the end of that in the bell crank. I've drilled holes so I can pin that later when I come to final assembly, after Warren's covered it in paint and I've scraped all the paint off the bearing surfaces. There we go. So that's the brake rigging installed. I can't put the motor in because I suspect that the body won't go on until I cut the shaft off the top there. And as I said, I don't want to start with a cutter this time of night because there's a bedroom on the adjoining house next to us.
Just drill a hole through the top of the firebox.
I could do that, couldn't I? And then we just offer that up to the bottom of there. To be careful now because the splashers have got backs in them, and the chassis has to go on the outside of the I can't see because Needs a bit of wigglage. There we go. You can always tell when it drops home, can't you? There we go. Happy with that. Nothing seems to be interfering with anything. Won't be when I've screwed the crank pin nuts back on. That turns quite nicely. So does that. So it's happy days there, I think.
Can we see it in profile?
And there you have it.
Yeah, it's looking good. It's coming on really nicely, isn't
Coming
it?
on all right, isn't
Yeah,
it?
very nice.
I've kind of got quite attached to it, actually, so much so that I quite look forward to coming up on Sunday afternoons to do a little bits and pieces to it. There's a bit that was, I put something on the forum about this. There's on the Lanky and York, sorry, Hull and Barnsley locos, I've got a weird bit on them that I can't really identify. I don't know if anybody has this information. The just here, there's
I
a
answered that for you.
weird sort of cylindrical thing there, and on the drawing it kind of suggests that the reverser's right up against the front of the cab almost, and part of the mechanism protrudes into a little sort of cylindrical shaped housing there. That's I think it touches the side of the firebox. I mean, if anybody's a Hull and Barnsley fanatic out there and wants to help me out and tell me what that is, then I'd be grateful.
I did reply to that post, Nick.
You did,
Yeah.
and you were right.
I think normally they do butt up against the firebox cladding.
So you think it's, where's my Sharpie? There it is. So if this is the sort of side of the firebox, you think it's kind of like that?
Yeah, probably. I mean, it's difficult to
Or
see that.
maybe like that.
Yeah,
And it's got a hole here, hasn't it, where the reach rod comes out of.
Yeah.
But I think actually when you look on the
it's probably rectangular,
photograph,
isn't it?
that's square, that hole there. And it's kind of like a shaped like a torpedo, like that. My Sharpie's dying. Shaped like that at the front, isn't it, as
Click on
well?
it.
Yeah.
Yeah, I mean, with it being that era, it's probably something they did for an aesthetic because it made it
Yeah,
like
yeah.
cylindrical and smooth and streamlined look,
I'd
rather
agree
than it
with
being
that.
brutish.
I'd agree with that. Yeah, so I need to find that out. It's obviously something that goes there, isn't it?
Mm.
But yeah, I'm quite pleased with how it's turned out. I mean, originally 2 years ago, was it 2 years ago when we started doing these in evening widths? The plan was just to do the just to show somebody how I made a smoke box, and here we are a couple of years later, and we've got.
Yeah.
Well, I mean, it's pretty much complete, the loco, isn't it? I was making a list earlier. It needs the vacuum pipe put in on the front of the loco. And who knows, I might continue the vacuum pipe a little bit underneath the footplate as well, because sometimes you can see it, can't you?
Yeah.
So that needs to be done. I don't think these locos would have had steam heating, would they? I mean, they're goods engines. Are they goods engines, these, or were they passenger engines? I think they might have been passenger engines or even both. But I don't think back in this era, carriages were heated, were they? I think in this era,
We're looking 1860s, 1870s.
yeah.
Yeah, foot warmers.
I don't think steam heating on trains appeared until the 1900s, did it? Or maybe a little bit before that.
1880s,
Was it?
possibly, unless anybody knows better.
It took a while, didn't it, to get to the sort of secondary routes as well.
Yeah.
But like you say, I think it was a source of income, wasn't it, for the railways back in Victorian times, because they could hire out blankets and hot water bottles and the like, couldn't they?
Yeah.
But anyway, so it's not got, from looks of the photographs I've got, the loco doesn't have any steam heating on it, so it'll not have a Mason valve on the foot plate, and it's only got one. It has, look, it's only got one pipe on the front of the loco, and that'll be the vac pipe for when you're going backwards. Yeah, so there's that to do. There's the lozenge shaped thing that the reverse reach rod comes out of, and then I think that's kind of it, really, isn't it? When we've got there, I think that's it. We're sort of done. And then I think what we're going to do after that is, well, it'd be churlish not to do the tender after. I don't know what you think, but we could maybe fit in another 3 or 4 an evening with doing a tender.
Don't see why not. That takes us on for another couple of years.
And in fact, look, here we have, as if by magic, the drawing of a Hull and Barnsley tender. And it's a bit of a challenge as well, look, because it's got a flare here in the corner. However, it's not a Great Western flare, is it? Where the corner of the tender's curved. This is just at a nice angle, so it'll be quite easy to form that.
Question from John Walker.
Go on then, John Walker.
Any tricks for grinding the shaft off the back of the motor?
Yeah, well, I always do it with a slitting disc in my mini drill, and I always get a bit of tape and push the shaft through the masking tape or electrical insulating tape just to try and stop ingress of anything, any grindings down into the bearing of the motor. And also I always go and get a bit of toilet roll soaked in water and just stick it round the bottom of the shaft as well, to try and act as a heat sink to stop the heat from the grinder going down the shaft and knackering anything that's inside the motor that, might get damaged by heat. But yes, the answer to your question is, the short answer is a mini drill, a slitting disc. It's kind of like a mini angle grinder, really, isn't it?
Yeah.
That's what I use. I know some people use big shears, don't they? But I ain't got any, so I can't. The other thing I was going to ask as well, before we shoot off, because it is getting quite close to closing time now, isn't it? These tenders it's got a 6 foot times 6 foot wheelbase, and I thought that something that would really help to make this tender would be to get an inner chassis, because of course traditionally in O gauge the tender wheels don't have outside axle boxes, do they? We have like a hidden sub chassis.
Yeah.
And the bearings are inside the wheels. And I know from past experience that once you start making an inner chassis, the hours really start to rack up because it takes quite a lot of time to cut one out and so on. So do you think it'd be cheating? Would anybody, if we were going to continue with this, which I think we are, would anybody have any objections if I just went and blagged an etched inner chassis off somebody like Dave Hill or Finny7 or somebody like that, just to speed the process up, so I wasn't going to be wasting everybody's time watching me cut out an inner chassis, unless you want to see me cut out an inner chassis.
Well, that's up to the viewers to. We'll run a poll on that one, Nick.
Yeah, run a poll.
Yeah. Peter Warren has just asked, back to brake blocks, are there any alternatives than custom 3D prints?
Yes, of course there are. I could have scratch built brake blocks, but it's very tedious. I've done it before. Basically, they're made out of 3 laminations. Well, it depends what kind of brake blocks they are. I mean, these are the conventional ones where you get one brake hanger like so, and then you get a brake block that kind of wraps around it like that, don't you?
Mm-hmm.
So the brake block's made out of 3 pieces. If you look at it from the side, you can take measurements off the drawing. What I would do is I would just simply draw a box around the brake block there and fill in the measurements, and then simply you just transfer those measurements onto a sheet of brass, and you cut a piece out, and then you repeat it for the piece on the back, and then you repeat that 3 other times for the other wheels, and then you have to make a center bit that's just a curvy bit that goes kind of in there. So you end up, if you look at the brake block from the top, you end up with something that looks like that. So this is one piece here. This is the second piece here, and that's the third piece, and it's pinned to the brake hanger, which sits here, if you're looking at it from the top. And it's just incredibly tedious. It takes forever to do it. You just sit there forever cutting out tiny pieces of brass.
It does indeed take forever, and I wondered if you had any fabulous shortcuts.
No.
The trouble with doing it in metal as well is you've got to avoid it shorting on the wheels.
Well, you have, but that's not as difficult. It's not really very difficult, that, because if you assemble it so that the brake blocks don't touch the wheels, then they never will touch the wheels, really, will they? It's not something that I kind of freak out about, that, because your wheels are located in your axle box, aren't they? They've got a bit of end float, but the wheel doesn't wobble about inside the wheel bearing, or at least it shouldn't, So that's not really something that I kind of worry about, that.
And the other option, of course, is a smear of 2-pack epoxy on the face of the brake shoe.
Yeah. If you want to go down belt and braces route, that's a good one as well, isn't it? Just to give yourself the extra bit of surety. But that's how I would have done them. It's just that I would have spent hours and hours and hours doing it, and I said, Mick, will you just Well, actually, I didn't. I wanted him to 3D print me the springs, because in the past I don't know whether anybody's ever scratch built springs, but they're quite easy to do, but they're a bit tedious. What I've got here, look, what I save in my little pile over here are these, and these are the ends of boiler bands. When you get a kit and it has a boiler band in it, and there's always a bit left. Well, these are the strips, and I always save them just in case. And in the olden days, I used to pile them up, cut them to different lengths, decreasing lengths, and you could pile them up and solder them together and make a spring. And I mean, whilst it's quite a satisfying thing to do, it does take forever to make one spring. You have to pile up the strips and solder them together. Then you have to make the strap that goes around them, and then the shackles on the ends. And making one spring can take you a day. And getting them 3D printed takes moments, really, doesn't it? But you need to know somebody who 3D prints. I don't know what you all think, but in a way, you kind of have to move a little bit with the technology, don't you? If these things are readily available, it's obviously going to be the way that these things are done in the future, isn't it? No one's going to start making springs by this method anymore, because you can just get them printed. In the old days, you used to go looking through Laurie Griffin's catalogue, didn't you?
Yeah.
Trying to find the nearest springs, or if you're building a great central engine, you might get in touch with Dave Andrews and ask him if the springs in his, I don't know, pom-pom kit were the same as yours, or maybe your Sam Fay kit or something like that. And it works pretty well for people that do Great Western, doesn't it? Because there's like 6 components from which all Great Western engines are made, aren't they? But other railway companies weren't quite so, organised, were they? So
Well, you say that, Midland had standardisation before the Great Western did.
Did they really? That's interesting. I did not know that.
As did that other company that unites our counties, Nick.
Which one's that? The Lancs and Yorks?
Yeah.
No, I was never hung up on that kind of thing, Ian. I lived in Manchester for ages, and I thought there wasn't a cigarette paper's width difference between Lancastrians and people from Yorkshire, or for that matter, people from Liverpool.
Yeah. Anyway, are there
Is that
any?
it?
Yeah, I think so. Any final questions before
Anybody
we
got
wrap
anything
up?
else you'd like to know? I mean, if you want to know else, just you can email me. Contact me offline. Message me through the the Gauge Guilds forum or Western Thunder if you're not a guild member. Happy to answer your questions. Spread the love. That's changed to the thingy view, so I
Back
can
to you.
smile at everybody one last time before I go downstairs for a beer. Hello, everybody.
Right, but while Nick is just clearing his workbench, I'm just going to share screen and do a quick PowerPoint for what's coming up for us all to enjoy. Okay, here we go. So next month we have Tony Andrews doing an evening with where he's going to describe his approach and methodology to painting carriages, which he basically looks at, as he says here, right from when the box is first opened. So that's 26th of March, 8 p.m. and tickets will go on sale midnight tonight. So that's for next month. Moving forward, in April, Alan Rhodes has kindly stepped in and he's going to do a session on how to put timetables together for your layout. So there are a lot of people who have layouts and just run trains, but there are many people as well now who look at actually timetabling the running of their layout. So Alan's going to touch on that and give us some really interesting examples. In May, it's going to be Dr. John Neeshaw coming back to us again with JMRI, and it's going to be part 2 following on from the session that he did in October, which was also with Julian Best, where Julian covered train control, which showed how you use timetables. So quite pertinent that we've got timetables and JMRI back to an extent. Then a repeat performance of Mr. Nick Dunhill in June with locomotive backplates. So that's what's the next one for you, Nick, before you go on another holiday probably. July, Chris Warner from Modern Image Outline Group is doing a session specifically about modern image modeling. So looking at examples of kits and items and products that you can buy to scenic or populate your modern image layout for those that want to look at doing those kind of things. August, John Jones, who's not a familiar name, is going to do a session on the Templot plug track and COT, which is chair on timber. John has been part of the development team for Templot 5, which is going to be open source software rather than Templot 2 and the original Templot, which was all developed by Martin. So there's a lot of developments within Templot in where it's going, certainly with being open source, because people can do things and add to it at a later date, much like they can with Decoder Pro or JMRI, which is also open source. And that would be quite an interesting session where you'll go through how you can 3D print your track before adding the rail. September, Paul Scott, who's with us tonight. Hello, Paul, again. We're going to visit his College Junction layout, which is a very, very nice layout that has been on the forum for a few years. And Nick approached him to see if he would be willing to do a session for us.
Thank you, Paul.
Yeah,
thank you for
Paul,
agreeing to
thank
do
you,
that.
Nick. October, Tony Andrews Carriage Painting Part 2, where he'll be looking at lining and pullmans. I think that's his main specific content for that night. And we're rounding up the year, November. Nigel Payne is going to do a Northeastern rail-mounted gun. Any non-members that are with us tonight, or any non-members watching this video, you can join the guild for a 3-month trial. So you get a 1 month free as a trial membership. If you then decide that you like what is on offer, you can join the guild for £30 a month for the UK, £35 rest of the world. But recently we have started a digital subscription where you basically get the Gazette and Guild news and publications in a digital format rather than paperback. And that subscription is £25 per annum, and I think it's £30 for the rest of the world, but don't quote me on that last figure. But all the details are on the Guild forum. If you wish to join, like I say, you go to the Gauge Guild website, top left, next to the little home icon, About Us, where the big arrow is pointing. You click on that, you get a drop-down box with Join Online option, which if you then click on that, takes you to the membership application form. And there you can see there's the current subscription rates and the annual digital membership, all communications by email, £25. So it does look like the digital membership at £25 is for the rest of the world members as well. So worth considering. It saves you an extra £5 if you don't want stuff coming through your letterbox.
Oh, I highly recommend it.
Well done, Nick. Thank you.
I highly recommend it. You get more of me.
Yes. And our social media content, we have content on Facebook, on Instagram, and I'm not sure what the two little balloons are. I think there's something else. And then, of course, the other one is YouTube, which the arrow is pointing to. If you click on the YouTube icon, it takes you to our YouTube channel, to where you can find 579 videos now are available for your entertainment and delectation, as they say. So it's certainly worth having a look at. Some very interesting videos on there, and we're certainly with the virtual show that's still ongoing until the end of the month. There's a lot of videos on there about demonstrations and also about some of the layouts that were covered. And a little Kettering Spring Show teaser video is on there as well for anybody who's coming along to Kettering. Finally, once again, Spring Show Kettering, Saturday 1st of March, this coming Saturday at Kettering Leisure Village, Thurston Drive, Northampton. Kettering, sorry, NN, Northampton, Kettering. And then the shows for the rest of the year: Summer Show at Kempton Park, 31st of May, Guildex, Bingley Hall, Stafford County Showground, 6th and 7th September, and the Winter Show, Robin Park Leisure Centre, Wigan, on Saturday the 6th of December. Here endeth the PowerPoints. So all I need to say now is thank you, everybody, for attending this evening. I hope you've learnt something and appreciated Nick's time. Thank you, Nick, as well, again, for another interesting session. And we look forward to seeing you again in June.
Thank you, Nick. Thank you.
As I said, if anybody needs any clarification, just contact me through the forum, or if you're not a member, Western Thunder.
Most interesting. Thank you very much.
Thank you.
Cheers, everybody.
Bye now.